Hello everyone, this is your Cisco trainer and welcome you to lecture number 6 from the course CCNA 200-301. It is a completely free course to pass the CCNA exam 200-301. And if you like the video, leave a comment and share to help us spread this free series of videos. And if you haven't yet subscribed to my channel, stay tuned please by just clicking on subscribe button, thumbs up, hit the bell icon, and do not miss the upcoming notifications. Topics to be covered in this chapter: routing, introduction, network layer of OSI model layer, Internet Protocol version 4, decimal number, binary number, conversion of base 10 to base 2, conversion of base 2 into base 10, conversion practice exercise. Now let's jump and start. Ethernet frame. Here I want to show you how layer 2 device learn its MAC address and how layer 2 device send Ethernet frame over the LAN. IP address 192.168.0.0/24. No worries about 24. In later section we will have a complete videos about. Just keep in mind it shows the dividing line between host portion and network portion. So each computer has its own IP address and MAC address. We have IP address 192.168.0.0/24 for PC1, 192.168.0.0/24 for PC2, and 192.168.0.0/24.3 for PC3, and 192.168.0.0.4/24 for PC4. Here it's the same LAN. How PC1 sends frame to PC4 or PC3, the target machine, which is the target machine, is depend on the computers. So now PC1 want to send frame. So PC1 broadcasts a frame on a layer 2 address FFFF.FFFF.FFFF. We have two types of broadcast address: a layer 2 broadcast address and layer 3 broadcast address. Here is a layer 2 broadcast address. All the F are called broadcast address based on layer 2 devices. So now PC1 sent broadcast address to the switch. Switch 1 received a broadcast address. Switch 1 sent the broadcast address to all that is interface except the interface which was received. So here PC1 sent a broadcast message on interface GEC 0/0. Now switch 1 received on GEC 0/0 interface. Now switch 1 broadcasted to all its interface except the interface which was received. It means on GEC 0/1, GEC 0/3. Now switch 2 received the broadcast address on GEC 0/3. Switch 2 broadcast the received frame or layer 2 address to all its interface except the interface which was received. Now switch 2 send the broadcast on GEC 0/1 and on GEC 0/0. So this is the process, but within layer 3 address the case is different. Now how switch 1 receive the broadcast address and or how it broadcasts. Now PC1 send the broadcast address PC2 to switch 2. Switch 2 receive it and switch 2 learn its MAC address. So this is the process how an Ethernet frame sent over the entire LAN. But within layer 3 address the case is completely different. Now let's check. What's routing? Introduction. What does mean actually routing? Routing means send layer 3 packet from one network to another network. So in this diagram the case is changed or the topology is changed. Layer 3 devices, a router, or it's also called layer 3 switch. We have a switch, it's belong to layer 3. The function is sometimes routing and also switching. It means they can do both function, has routing and switching. Here we also have a two IP address. So two broadcast domain in here. We have one network in the right hand and also we have another network in the left hand. So routing means the process of sending layer 3 packet from one network to another network. Now in here we have two LAN. We have two segments. So when PC1 send a frame to a switch 1, so switch 1 broadcasts it to all its interface except the one which was received. But now router does not forward broadcast. Router block it. So here let's see how. Now PC1 sent a frame on its interfaces gig 0/0. Now switch receive it and learn its MAC address. Switch broadcast the frame to out its all interfaces except the one which was received. But here now, in between these two LAN we have a router. Router does not forward a broadcast message to other computer. So within layer 3 address, we send from one computers to other computer, from one network to another network. It is the option or the functionality of a layer 3 address. So it is called a routing introduction. Why I mentioned about layer 3. Now let's speculate layer 3 and how it option. The network layer responsibility is for the delivery of individual packets from the source host to destination host. Provide connectivity between end hosts on a different networks. It's the job of layer 3 address. Provide a logical address IPv4 or IPv6. Provide path selections between source and destination. Layer 3 devices include router and switch. Or the process how network layer operate or how network layer sends data or packets from one computer to other computer over entire networks. This is the functionality of the network layer. Internet Protocol version 4 or IP address. As I mentioned for you guys, no worries about what does mean /24. Here we have an IP address 192.168.0.0. It's a class C IP address. /4 is the dividing line between the host portion and the network portion. Now let's see how we convert a decimal number into binary number. As you guys know, the computers only operate on a physical layer. Then second layer is a data link layer and the third layer is a network layer. So we followed the process of OSI model layer. In the first lecture I have told you about physical layer. In the second lecture of the OSI model layer I told you about the data link layer or MAC address or layer 2 addresses. In a previous lecture we have a complete discussion on layer 2 devices. Now we talk about the layer 3 address of the OSI model or IP address. Now let's see. We have a complete view of the IP address, how computer convert a decimal address into binary address. So decimal addresses, it is a 9 digits. So in here an IP address has written with a decimal dotted decimal notation 192.168.0.0. IP address now divided into a binary portion, a binary bits. So we have octet 1, octet 2, octet 3, octet 4. So in here we have 4 octets. A complete portion of IP address, it is divided into four octets. Each set's called octet or portion or 1 byte. So in here, how we divided? 192 is corresponding to 110000, and also the next portion and the next portion and the next portion. So these 4 portions means a complete view of IP address, how we convert a decimal address into binary address. IP address. It is a 32-bit decimal address commonly written in a dotted decimal notation, made up of 4 sets of 8 bits. Each set's called octet. Portion are 1 byte. Decimal number and binary number. The number system which provides 0 to 9, commonly called base 10, or decimal number system, is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It is a complete decimal system numbers. The number system which provide 2 digits of number, ones and 0, commonly called base 2 or binary number system. Zeros and 1. The computer electronic machines all operate based on binary numbers, 0 or 1s. 1s means on and 0 means off. So IP address, if we have an IP address 192.168.0.10, corresponding to decimal number. So each octet, the above IP address, has consist of 8 digits or 1 byte, which depict in below. 192 is equal to 110000. 168 is equal to corresponding binary address 10101000. 0 is a completely 0. It is corresponding to zeros. Either you can type only 10 or you can type it 8 zeros. 10 means 000. 1010. It means the portion of 2 is on and the portion of the heading of 8 is on. Now it's make it a 10 and a decimal and 0001010 in binary. Conversion decimal into binary. The process of how to make or how to convert a decimal number into binary number. Try to make a construct binary conversion table for you. So it makes very easy for you how to change it from decimal to binary or vice versa, or from binary to decimal. The process is really easy. Try to make a construct a binary conversion table. So the construction or the construct of a binary conversion table is 1, 2, 4, 8, 16, 32, 64 and 128. So how we type this? It is a power of 2. Why power of 2? Because 2 is the binary number. We have 2 digits in a binary number. 2 to the power of 0 is 1. 2 to the power of 1 is 2. Just make it double. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. To the power of 6 is 64. To the power of 7 is 128. So now let's check. Let's check the following binary number: 10, 10, 1000, or 10101000. How to convert it? How to change it? So it is corresponding to decimal number 164. The place of 128 is 1. In a 64 portion we have zeros, and 32 we have 1, and 16 we have zeros, and 8 we have 1, and the rest of is 0. We just header of 1, 62, 8. So 128 plus 32 plus 8, it is equal to 160. A given decimal number of 156. Calculate the corresponding binary number. We have a construct a binary table: 1, 2, 4, 8, 6, 32, 64, 128. As I told you, try to make it provide for yourself, and keep in mind it's make very easy the process of how to convert from decimal to binary. Is 156 is greater or equal than to 128? We just mentioned, or we just think about the heading column of 100 or 164 or 32 or 16 or 8 or 4 or 2 or 1. So it shows 126 is greater than 128. So just place 0 on the position of 128. Yes, it's greater. Place 1 in the column in 128 column. Subtract 128 from the 156 is equal to 28. Note, continue the same process until you acquire the corresponding result. 26 is greater or equal than 64? No. Place a 0 in the 64 column. Is 26 is greater or equal than 32? No. Place a 0 in the 32 columns. Is 26 is greater or less than 16? Yes. Place 1 in the 16 column. Subtract 16 from 28 is equal to 12. Is 12 is greater or equal to 10? 80? Yes. Place 1 in the column of 8. Subtract 12 from 8. Now it's equal to 4. Is 4 is greater or equal than 4? Yes. Place a 1 in the column of 128. Subtract 4 from 4 is equal to 0. Is 0 is greater or equal than 2? No. Place a 0 in the column of 2. Is 0 is greater or equal than 1? No. Place a 0 in the 1 column. A given decimal number of 156 is equal to 100, 111, and 0, 0, or 1, 0, 0, 1, 1, 0, 0. It's the process of how to convert from decimal to binary. Let's check another example. Fraction method. A given decimal number of 164. Calculate the corresponding binary numbers. We have different method how to change from binary to decimal. So the first one is called a fraction method, decimal into binary. The given binary number or the given decimal number is 164. It is other methods, the difference method how to change from decimal to binary. So in here we divide 162 by 2. Why by 2? Because the base number of a binary number is 2. So we divide it. It is a 81. The remaining point is 0. Then we divide 81 by 2. It's 40. The remaining is 1. Again we divide 20 into 2. The remaining is 0. We divide 10 into 2. The remaining is 0. We divide 5 into 2. The remaining is 0. We divide 5 2 to 2. The remaining is 1. And 1 to 0. It is 0. So 162 in base 10 is equal to binary 1 0 1 0 0 0 1 0, or 10 thousands and 10. It's the process of how to convert from binary to decimal to binary in a fraction methods. Now let's check another method. It is called geometric method. It's really awesome with the geometric. The students will able to convert base 10 into base 2 with less effort. So we write the total number or the given number from right to left. Here we have 162 divided into 2 portions. It is 82. Again we divide it into 2. 40, 20, 10, 5, 2, 1. Now identify the odd and even column. So 1, 5, 81, it is odd, and 2, 10, 20, 40, 164 is even. Place 1 in the odd column and zeros in a even columns. So we just place it 1 the column which is odd, and we place 0 the column which is even. Now let's check the result. Both the result are same. We have 10 thousands 10 in a geometric as well. We have 10,000 in a fraction method as well. This is the process of how we divide or how we convert from decimal number into binary number. I love the geometric. The geometric made really easy, so try to practice with the geometric as well. Conversion of binary into decimal. Method. Write binary number in a power of 2. Calculate the power. It will give you the desired number in decimal. Questions. We have a binary number 10, 10, 10, 10 with the base 2. Now convert to decimal number to base 10. Construct a binary conversion table. 1, 2, 4, 8, 16, 32, 64, 128. We just rise to the power of 0 to the power of 1 to the power of 2, a binary number. So place your binary number under a conversion table. 1, 0, 1, 0, 1, 0, 1, 0. Now add all ones header together and the result will be in a position of 128 we have 1, in a column 32 we have 1, in column 8 we have 1, in column 2 we have 1. So now we added 128 plus 32 and plus 8 plus 2. The result is 170. Now let's check the other method. We multiply all binary numbers by 2. So in here 1 times 2 to the power of 7. 1s times 128 is equal to 128. Zeros times 2 to the power of 6 is equal to 0 times 36. It is equal to 0. Each number is multiplied by 0. The result is 0. 1 times 2 to the power of 5. The result is 32. 0 to the power 0 times 2 to the power of 4. It is equal to 0. 1 times 2 to the power of 3. It is equal to 8. 0 times 2 to the power of 2 is 0. The result is 0. Or 0 times 2 is equal to 0. 1 times 2 to the power of 1 is equal to 2. 0 times 2 to the power of 0. It is equal to 0. So this is the process of how to change from binary into decimal. Now we add all the position. We have 128, 32, 8 and 2. The result is 170. This 2 methods is used how to change from binary into decimal. Conversion practice. Number 1. Convert the following given decimal number into binary. Pause the video and check your result with what I have solved. Questions number 1. 128 from base 10 to the base 2. Question number 2. 256 from base 10 into base 2. Question number 3. 96 from base 10 into base 2. The second question is from binary to decimal. Number 1. 10, 10, 10, 10 from base 2 into base 10. Question number 2. 10, 11, 10, 11 from base 2 to base 10. Question number 3. 1, 0, 0, 0 from base 2 into base 10. So try to solve with yourself and pause the video, then check. Routing. Introduction. The process of routing is send layer 3 packet from one computer to other computer over the entire networks, or from one network to another network. Network layer of the OSI model. Provide connectivity between end hosts on different networks. Provide a logical addressing IPv4 or IPv6. Provide path selections between source and destination. Layer 3 device as a router. Also we have a layer 3 switch as well. A decimal number. A system number which provide 10 digits of number from 0 to 9. It is called a decimal number. Binary number system. It provides two digits for us, ones and zero. Ones mean on, zero means off. Conversion of base 10 to base 2, conversion of base 2 to base 10. Thanks for your watching. That is all for this video. If you want to show your support, please subscribe the channel, like the video, leave a comment and share the video with anyone else studying for CCNA.